This is lecture number 2. This is on mapping of S-plane. Mapping of S-plane into Z-plane. In lecture number 1, we have seen that the left half of the S-plane has been mapped with the interior of the unit circle. Right half of the S-plane is mapped with the exterior of the unit circle, and the imaginary axis is mapped with the periphery of the unit circle. With this small recapitulation, we will go to the topic, that is mapping of left half of S-plane, mapping of left half of S-plane with Z-plane. For this, we will divide S-plane into some strips. In this manner, each strip is from n minus half omega s to minus j to n plus half omega s. Each strip is of width from j n minus half omega s to j n plus half omega s. So when n equal to 0, when capital N is equal to 0, the strip is in from plus j omega s by 2 to minus j omega s by 2. This strip is known as primary strip. This strip is known as primary strip. Then for n equal to 1, for n equal to 1 or other integer, for n equal to 1, let me consider another strip, that is from j omega s by 2 to j 3 omega s by 2. So this is another strip, and it is known as complementary strip. These are known as complementary strips. In this manner, entire S-plane can be divided into several strips, that is primary strip and complementary strip. Now, to map the left half of the S-plane with the Z-plane, let us only consider the left half of the S-plane in this particular figure. So this is the left half of the S-plane, and the primary strip in the left half of the S-plane is having an imaginary boundary that is A, B, C, D and E. So this boundary A, B, C, D, E represents the boundary of the primary strip. Is the boundary of the primary strip in the left half of its plane. Boundary of primary strip in left half of its plane. So let us consider the boundary of the primary strip in the left half of the S-plane in anti-clockwise manner. To understand the value of Z in the Z-plane, let us first consider the coordinates of the points A, B, C, D, E. The point A here, the coordinate is sigma is equal to 0 and omega is also equal to 0. So, the coordinate is 0, 0. For B, the coordinate is 0, omega s by 2. For coordinate C, it is minus infinity omega s by 2 and coordinate of D is minus infinity minus omega s by 2 and coordinate of E is 0 minus omega s by 2. So, if we traverse from A to B, the value of Z is equal to 1 and the angle varies from 0 degree to 180 degree. 0 degree to 180 degree. Let us plot it in the Z plane. If it is the Z plane and we plot this point, that is from 1, Z equal to 1 to plus 180 degree. Let us consider this point as A and suppose this is varied in anti-clockwise direction and this is the point very near to the x-axis, negative x-axis. This point is B where the angle is 180 degree. Now if we go from B to C, it is seen that the value of Z will tend to 0 as the coordinate of C is minus infinity, but the angle will remain 180 degree only, or 180 degree or plus pi. So this value will go to this and this is the value where Z is equal to 0. So this point can be considered as C. Now from C to D, the mod Z value is equal to 0 and the angle is minus 180 degree. So C and D, they coincides with this point and this is the point D. This is the point C and D. Sorry, this is C and D. Now, from D to E, again, mod Z starts from 0 and ends at 1 as the magnitude x coordinate of E is equal to 0 and the angle is minus 180 degree. So this point is E. Now again, if we go to the point A, we can get this path. So from this point, it is evident that the boundary ABCDE, which is the boundary of primary strip in the left half of the S-plane, it is inside the unit circle, and in the Z-plane also, this ABCDE boundary, it is the periphery of the unit circle. So we can say that the primary strip of left half of S-plane can be represented by the interior of the unit circle. Interior of the unit circle.